The following help video is based on our new generic receive setup in some of our newer products. Some of these products are the all-wheel drive controller, our new tiny display, and water and methanol, etc. These have all of these new generic receive options. And what the generic receive means is that basically it can cater for pretty much anything that you're trying to receive from a CAN bus and assign it to an item based on the product you're using. Currently, I'm using the all drive generic unit here just for the example setup. But any of our products that do have this function available, you can set them up. And the difference is purely just on the items that are available to be seen. So with the generic all-wheel drive in here, the listed items are only the items which you can basically assign to the generic receive functions or CAN messages to receive. But other modules do have the ability to have obviously more items depending on what the product is used for. So let's go over this generic receive section and understand exactly how it first of all works. So the first obviously map that you see with CAN bus is the speed in which the CAN bus is functioning at. For this example, I've got it set at 500 kilobits, and I'm using another piece of software connected to an external device to actually transmit CAN into the unit. Now, currently nothing is actually working on the unit, no data is coming in. You can see the lateral G, long G, etc. is moving, but that's because of an onboard accelerometer that's on board of this product. But apart from that, all the other items are pretty much just zero, or their default value. So let's go through and understand then what you need to set. So you've got the content identifier, endiness, start bit, bit length. You can see them all there. Now, when you're going through these, it can be quite tricky to just keep going through each one of the maps. So you can see here, okay, so I want to set in CAN RX01 slots, the RPM, and then do I want that, what identifier do I want that to be on as 600? The reason we do it that way is we had to lay it out this way with the map software. But there is a much nicer way that you can lay this out, and that is using our worksheets. So up here, go to worksheet and then new. We can just put in here test, and you'll basically see that the screen has gone blank. Now what you can do is go worksheet and then add cal. So what I'm going to type in is I'm just going to type in generic, and you'll basically see all of the generic receive maps that come up. So I'm just going to actually highlight all of these and then go OK. And basically what it does is it opens up all of these maps, and what you can now do is actually change these and line them up on the screen. Now, if yours is showing like this, which has got the text and the graphical view, just click on that window and then go options, and then you can change here the type of view. So at the moment it's on both. You just want it on textual, so you can just see the raw value in a kind of textual format. So to speed things up, I've actually kind of a moment here. I've done this actually before, so I'm just going to worksheet and then generic RX, and you'll see how let me just cancel this one down. You'll see how I suggest you lay it out. And this is a really useful way of doing it, just because you can see everything in a line of what you're trying to do. So for example, my RPM is looking at the 600 identifier, a start bit of 0, a length of 16. It's not most significant byte, so it is most significant byte. It's not little endian, and the item is signed. Then you've got your raw scaling here. Now, if you understand CAN bus and you've got some DBC files from, say, some of the ECU manufacturers, this becomes really easy to then set up, because you know the basic start bit position, where it's going to be, and you can put your scaling in. If you don't know that, then what you can do is use a piece of software like Netronics Can Do, which I'll show in the bottom of the screen here. Basically, what that allows you to do is read the CAN bus that is on your car, and then you can start to decode that. Now, the guys at High Performance Academy have done a really good video on CAN and understanding it and reverse engineering, etc. Suggest you watch that, get some notes from that, and then you can use that in here to basically get your items in. So let's have a look at my software that I'm using to transmit some of the CAN in. So I'm transmitting a CAN frame at the moment, which is 100 hex, and basically on that I've just got 5 bytes of data being sent currently, and I'm sending it at 500 kilobits. And I've just got in here the RPM, TPS, and speed. I've just chucked in some values here at the bottom just for the purpose of the video. So what you've got then, when you're looking at this in a CAN structure, you can see here you've got 1388 hex, and that's what is being defined here as RPM over 16 bits of data. So what I'm looking at, obviously I know that this is a most significant byte layout of CAN, and like I said, the high performance CAN will help you understand which way around that is. So what I'm going to do is I'm going to say, okay, well I know that the start bit position of this is 0, so the most significant byte is first, so that's the first bit here, which is in that, so where it's F there, and I know that it's 16 bits long. So what I'm going to do is I'm going to come back to my software here, and I'm going to say, okay, RPM is going to be on 100 hex, start bit position of 0, length of 16, it's not little endian, and it's not signed either. Once I've done that, go program, and you can now see that the RPM is coming in. Now, let's say that this RPM value here, at the moment it's just a one-to-one scaling, but let's say that you actually wanted the actual scaling for this was say 0.25. When you're in here, you can then come into this option here and go 0.25, program that, and then you can see it is a quarter of the messages being added. The raw offset here is some CAN messages have a offset applied, generally coolant temperatures and stuff like that, where you can basically change the value and offset it by a certain amount. So if I wanted to put in here minus say 10, I can do that, program it, and then it would take off a 10 unit in its decimal as the raw item coming in. It won't take 10 off the actual variable, it takes 10 off the raw variable of the CAN. So the 16 bits of data, it would take 10 off that. Okay. Now, if you had an 8-bit item for say temperature, then that would line up correctly with that. But because this is a 16-bit integer, that's why it's done that and moved it so much. So, okay, let's have a look at the next one. So TPS. Now I can see here that TPS, just looking at it, is in the second byte. Generally, when you're talking about CAN data, the first byte is 0, then 1, then 2. So I can see that is 32. So basically, that's actually going to be the start bit of that item is going to be 16, because it's 16. You start at bit 0 for your start bit originally of that first frame. So 16 bits along, your start bit is going to be 16. Now this item here is only 8 bits long because I'm looking at just the single byte of data. So what I'm going to do in here is I'm going to say, okay, TPS and PPS, I suppose, can both be the same thing. Just highlight both of those, 100 hex, 16, 16, length of 8, not signed, and then program that. And you can see the TPS and PPS is receiving based on the raw one-to-one scaling of what is being sent on here. Again, if you need to scale it, you just scale it here. So the generic CAN receive, as you can see, is a really powerful tool to allow you to take these kind of generic units, like our new Tiny display or these generic all-wheel drive units, and get all of the data you need in to your unit. Now, on some of our units that we have, they do actually have a preset CAN. So there'll be a preset CAN window underneath here, which we've got all of the information of a lot of the OEM cars already. We don't actually have that on the generic all-wheel drive product, and the reason for that is because some of our plug-and-play kits, where we've spent a lot of time reverse engineering the CAN, etc., are part of that, and we don't want to basically take away other people's work. The generic CAN transmit and the flexible CAN transmit are basically similar in function to what the generic CAN receive is, especially for the flexible, where you can assign a start bit and a length, etc. I'm in here, and then the generic CAN transmit is just basically fixed as 16-bit integers. So I can actually just do that now. Let's just send out something on 200 hex, frequency, say 10 hertz, not endian, and I'm just going to chuck in some values in here. There's some already in there. And when we ping that out, you can then see on the CAN unit that I'm using, all that data is being sent out on the 200 hex. So hopefully this video has been really useful when helping you be able to understand how to use the generic receive setup of the CAN unit for this. The generic receive of our ECUs is a bit different. So this is purely for our kind of products that are the all drive, display, water methanol, and a few other new products that are going to be coming out soon. But the generic receive for the ECUs is different, and that is explained in another video. So hopefully this video has been really useful and allowed you to get to grips with the generic CAN receive setup that we offer in our products. Okay, look forward to seeing you on the next help video.